So Yoni, what is an incremental model and like when do we want to, or incremental load of data or transformations, and when do we want to do that?
So, I mean, when you're talking about a data warehouse, you want to load data in as you receive it. So you get all new data once a minute, once an hour, once a day, once every however long. You want to load this data into the warehouse. And generally, there are two ways to load it. Either you can say, well, every time I want to make an update to the data, I'm going to just reload all of it. And this is actually pretty convenient, this like truncate and reload strategy. It's also, if you're using dbt, that's the default strategy. So by default, it's going to truncate all the data and then reload it. And that's useful because then you can use SQL kind of naturally in order to define all your transformations. And you don't need to worry about anything. So you can do any kind of nested SQL statement that you want. It's kind of the full-fledged ELT, just run whatever you want on all your raw data and get it into the target. And this breaks down when you have a ton of data. So let's say if you have 10 gigs, 50 gigs, maybe 100 gigs of data, you can feasibly do a full reload. Maybe not every minute, but you could do it like every day or something like that. Maybe even in terabytes, you could still do a full reload every day. But if you want it to update every minute or every 15 minutes or something like that, or if you have a lot of data, if you have 500 terabytes, then full reloads are just not practical. They're too expensive and they take too long. And that's where you're going to want to do incremental loads. So an incremental load divides into two parts: getting the data into the data warehouse. Generally, loads from outside the data warehouse are always incremental and depend only. So you're always going to be loading in new data incrementally, even if it's just a tiny bit, with a few exceptions. But generally, that's going to be the case. But then the tricky part is then when you have all your data in a staging table. The first table has all your data, and you loaded this small increment. Maybe you loaded a couple hundred megabytes or something like that. And now you want to update all of your downstream tables. So your ELT process, you want to trigger it. So you have, let's say, all your dbt models that are transferring data from the source tables to the target tables, and those dbt models are full reload models. And now you want to do it incrementally. So dbt conveniently has an incremental model. But so that's basically like, this is what we're talking about, is using the dbt incremental model. And the reason you're going to want to do it is because your data volumes are high enough that that it's either prohibitively expensive to do a full reload, or that the full reload just takes too long and it doesn't fit with the data freshness requirements you have. So that's really the motivation to be doing incremental models.
So the task is to identify what the new data is that has arrived, like the incrementally new data in the staging table, let's say, and then run the transformations on those for subsequent tables, downstream tables.
Yeah, so I think that like when you start working with incremental models, the first thing that you need, like you said, the first thing you need to do is kind of identify what is the new data. Like, what is the data that's actually been updated, and what's the relevant data for the query. So simple example, I have data coming in that's like, I don't know, user data, user events. And all I want to do is clean it up a bit. Let's say it arrives as a nested object. It has some fields that are with the wrong data type. And I really just want to do a straightforward transformation, maybe filtering out a few rows. So I really just want to run a query. There's no group by, no aggregation, not anything kind of complicated. But I need to run this only on the new rows. I can't run it on all the data that ever showed up. So how do I identify these are the new rows? So there are a couple of strategies to do that. The simplest one by far, and this is also, if you go into dbt's documentation on incremental models, this is kind of what they recommend, is have a column that's monotonically increasing. So new data only ever gets added with higher values than all the existing values, and do where the value of this column is greater than the maximum value of that column in the target table. So that's kind of a very, very straightforward, easy solution. Um, and it's usually going to be wrong. It's usually not going to work out. And this is kind of a pretty big gotcha, because this is what DBT recommend, and from a sanity correctness point of view, this is actually the way to go. The issue is that you need to have a column that is guaranteed to be monotonically increasing um, in your data warehouse. And it's very, very difficult to actually create a column that's monotonically increasing. Um, Most data loading tools, Upsolver excluded, but pretty much any data loading tool that is not Upsolver doesn't guarantee order of inserts. So by definition, if I have two inserts and I don't guarantee the order between them, I'm definitely not going to be monotonically increasing, because if one is bigger than the other and they can come in the wrong order, then by definition I'm going to fail at that constraint. And and that's a bit tricky, because then if you're using this strategy, what's going to end up happening is that you're going to lose out on data. Basically, you're going to get the larger value first. You'll run your ETL, you'll filter, get all the new data, and everything will be fine. And then the next iteration is going to miss the older data that came in later. So this lack of strong ordering is going to cause you basically to lose data downstream. And when you lose data because of reasons like this, it makes it very hard to reason about your pipelines in general. Like I had 1,000,000 events coming in, now I have 800,000. Is that correct? Did I filter out because some of the events were broken and I had a where clause that filtered them out? Did I lose the data? Are the sums, like my sums aren't adding up? Like what's the root cause? How big is the problem? It's very, very hard to figure these things out, because it's not a reproducible side effect. It's something that's going to happen as the ETL is running. But then if you were to rerun that ETL an hour later, it would work. Like you would get all the data. I mean, it's really just because as it happened when it ran, you didn't have all the data in the table. A few minutes later, it would have been fine. So it's a timing issue that then is very hard to reproduce and very hard to know what was affected by it.
That makes a lot of sense. Yeah, I've done loads previously where like I had to create that like high water mark, right? Like find something in the data, or create based on a timestamp or something, a way to figure out like where we are to, right now, and then how much the next data will be. And it works if there's like a field that is guaranteed to be monotonically increasing, right? But you're sort of or I was relying on an external systems, guarantee that, okay, this is like a serial number, right? It's only going to go up, and say, okay, we're up to here. Let's go from there. But it definitely, like, if that guarantee breaks from that external system, I don't have any way of like controlling that. And yeah, like if things arrive, if something arrives to fill in a gap from an earlier data point, like what we would refer to as late arriving data, that's also that like the engineer would have to think really hard on how to handle that, if they were doing it in a bespoke way. And for every different data source, right, it would have to be something bespoke.
Yeah, exactly. And it's actually quite a lot of work for the engineer. I mean, it's not like kind of the way we represented it now is, I mean, it's complicated, but at least the problem is very isolated. But this is kind of ignoring ETL failures. So it could be, for example, that your ETL ran and failed in the middle, or it could be that the same ETL is running and then it runs in parallel to itself. This is, by the way, not recommended. So like you should try to avoid this happening. And for example, Snowflake gives you some locking abilities that can prevent concurrent running. But this is also something that you're going to have to code into your ETL pipeline. And like you said, it's bespoke for each source you're going to need to handle separately, and each pipeline is going to need to have all of this recovery code within the configuration of the pipeline and within the SQL statements that are running. And that makes all of your SQLs a lot more complicated. So it's a lot of boilerplate that if you get it wrong, everything's going to be horrible. But it's a lot, and it kind of dominates the size of your queries as well in a lot of cases.
So what are we proposing? Like as Upsolver, we're proposing to do this a little bit better, right?
So Upsolver sidesteps the problem because we actually provide a monotonically increasing column. So Upsolver, when you load data into a data warehouse using Upsolver, you're going to get one or several, kind of the one that you're always going to get is event time, and you can also get additional columns like commit time or things like that that are also guaranteed to be monotonically increasing. But at the very least, you're going to have an event time column, and that event time column is guaranteed to be monotonically increasing as you would see it in Snowflake. So you would never run, there would never be a query that you can run in Snowflake that would get event time 10 in the morning, and then the next query that you run, or any query that you would run after that, would not be able to get more data that is before 10 in the morning. It would have to be after. So never will you get data that's newer and then data that's older show up later in any query that Snowflake can run. So this just sidesteps the problem. You can do what DBT recommend, run your incremental models, use the where clause that's kind of a one-liner, and it'll just work. Like your ETLs, your ELTs will be correct, and they'll get all the data. So you're going to have exact numbers kind of between the source and the target. And Upsolver also gives you a lot of metadata around that so that you can actually compare. So you know exactly how much data we intended to load, and you can run your queries on Snowflake to see that hey, yeah, I actually did get that amount of data in these time ranges. You can compare on the values of the event time itself in order to know like exactly how much data was supposed to arrive in each interval. Yeah, so that just sidesteps the problem entirely. If you were wanting to do this without Upsolver, without having an external system giving you a monotonically increasing column, then basically what you need to think about is how do you identify what you already loaded? How do you identify the rows that you already loaded? So one strategy might be to load all the data, like for every load, you might want to also load all the data or just the primary keys within the same transaction into a separate table, and then join and filter based on that. Of course, these tables also get large, and large joins between tables are expensive, so you want to make sure to maintain that. You can also work with staging tables, so you can load all the data into a staging table, consume it, finish consuming it entirely, and then remove it from there. And then the next batch will be all the data that's there. Now, again, this is a bit tricky because then whoever is writing to the table is making updates, and also whoever is reading from the table is making updates. And if you're not careful about what happens in which transactions, you can get kind of as if dirty commits, so where you're going to see some of the data, and then in the next part of your ETL, you'll see a different part of or you'll delete more data than you intended. So it's a solution, but you have to really think about kind of how everything interacts within your system when you're doing that. Also, it means that you're not going to have your source table with all of the history, which often is a valuable thing. You can do another copy into another table and then empty the staging table after all the ETLs finish. But yeah, so that's, it gets complicated pretty quickly. Honestly, I think that big data engineers working in an ELT context, so working in a data warehouse, most of their time is going to be spent on things like this. Like this is what they're dealing with most of their time. And then some of their time they also spend actually doing the ETLs, but they're usually a lot simpler.
Yeah, it's a real pain point, and I'm glad that we have a solution for it. Awesome.